Hey everyone, welcome to This Explainer. Okay, today we are diving headfirst into literally one of the most intimidating environments in the entire tech world. Yep, we're talking about the legacy codebase. We're going to explore this through a brilliantly crafted narrative I read recently from a tech blog. It follows this junior developer named Timothy and his incredibly wise senior mentor, Margaret. Look, if you've ever stared at a monitor full of ancient, completely undocumented code and actually felt a cold sweat forming, yeah, this explainer is exactly what you need. So let's jump right into this story and see how artificial intelligence, specifically Claude Code, completely transforms the way developers tackle these legacy monsters.
So, our story kicks off with Timothy. He's just been handed the keys to a 12-year-old legacy system. And get this, 3 different teams have touched it over the years. The original architect is long gone, and the documentation, hopelessly out of date. Naturally, he's been asked to add a moderately complex feature. He goes to Margaret and tells her, quote, "I have been reading the code for 4 days, and there is one function that I am genuinely afraid to touch." I mean, what a cold open. It just absolutely hits the nail on the head, capturing that deeply relatable panic of facing down an old system where the code technically works, but literally nobody understands why.
And what exactly is he so terrified of? Well, it's a function called, super helpfully, process data. The exact specs of this roadblock are honestly pretty grim. We're talking 430 lines of code, 0 comments, none, and it was written by someone who left the company 6 whole years ago. But it stands right smack in the middle of the path Timothy needs to take to build his new feature. I think we've all encountered our own version of process data, right? That massive, monolithic wall of text that basically looks like it's written in an alien language. Timothy tries to explain to Margaret how it feels to navigate this beast. He compares it to arriving in an unfamiliar city, where you don't know the history or why the roads bend the way they do. But Margaret points out, and this is such a brilliant way to frame the reality of our work, it's actually much harder than that. You can't just casually stroll around a code base and observe things like you can in a city. She shifts the metaphor completely. She says, no, it's not a city, it's an archaeological site. And that brings us to Margaret's crucial definition of what a legacy codebase actually is. The artifacts, the actual lines of code, they're present. You can see them. But the context? The context has been completely lost to time. The people who made those original decisions are either gone or they've just forgotten. And your job as a developer isn't just to carefully excavate and study the ruins. Oh no. You are expected to build brand new, functioning things directly on top of them without disturbing the old structures. Talk about high stakes, right? So to survive this high-stakes archaeological dig, Margaret lays down the absolute golden rule. Are you ready? The legacy codebase must be read before it is touched. Period. And she doesn't mean just skimming through it real quick. She means reading it with deep, focused attention. You have to start from the entry points and carefully trace the paths inward. You absolutely cannot just jump in with a shovel and start hacking away at the artifacts. You have to observe them first. Now, here is where the story introduces a total game changer. Timothy reveals he's been using Claude Code to help him do this reading. And Claude Code isn't just regurgitating or summarizing text. It's acting as this expert companion. It actually names the architectural patterns. It points out when an unusual implementation is really just a known pattern done in a weird way, or when a piece of code was clearly built around a technical constraint that literally doesn't even exist anymore. But most importantly, it gives developers the actual vocabulary to think about and discuss the code they are staring at instead of just sitting there feeling completely overwhelmed by it. Because of this, Timothy shares a massive breakthrough with Margaret. He took that terrifying process data function and showed it to Claude Code. And listen to what Claude told him. It told me it looked like a pipeline processor with manual state management. Wow, Claude actually recognized what the original developer was trying to do all those years ago. It even noted that if you were building it today, you'd just use a standard streaming library. Now, Margaret rightly points out that knowing this doesn't necessarily make the function less frightening to edit, but it makes it less mysterious. And stripping away that mystery, that is the absolutely vital first step to working safely. This breakthrough organically builds into a very concrete methodology. Margaret teaches Timothy a 4-step process for moving from just staring at the code to actually understanding it. Step 1, read the interface. Step 2, form hypotheses about why things are the way they are. Step 3, test the behavior. And you do this not by changing the code, but by asking targeted questions. And finally, step 4, document your understanding. Having this structure, it completely takes the panic right out of the process.
Let's actually drill down into step 2 for a second, forming hypotheses. How do you practically do that? Well, you ask powerful prompts. When using Claude Code, Margaret suggests showing it the puzzling snippet and asking really specific questions. Things like, what problem was this solving, or what constraint would explain this choice? You can ask Claude to propose, say, 3 reasons why a developer might have made this bizarre choice. Now, Claude doesn't know for 100% sure, but generating a list of logical possibilities dramatically narrows down the space and helps you zero in on the truth. During this whole discussion, Timothy brings up a caching layer he found that looks completely broken. He's convinced it's a bug, but Margaret introduces this really profound shift in perspective. She tells him to consider this idea. The workaround becomes load-bearing. Think about that. What looks like a glaring bug today might have actually been a really quick hotfix years ago, and over time, the entire rest of the system was built to expect that specific buggy behavior. And this leads us to exactly why modifying unexplained code is so incredibly dangerous. It's exactly like renovating a super old building. Over time, systems just accumulate workarounds. Original bugs evolve into expected features. If you march in there and just fix a piece of code you don't fully understand, you might accidentally knock down a massive structural pillar. That unknown code might literally be the only thing holding the whole system up. Okay, right about now, you might be thinking, how on earth do I ever learn everything about a 12-year-old system? Well, the really good news is you don't have to. Margaret reassures Timothy with this incredibly vital piece of wisdom. Complete understanding is impossible given the time constraints of a real job. Your actual goal is sufficient understanding. You just need enough context to safely add your new feature without breaking what already exists. Doesn't that take the pressure off immensely? But listen, sufficient understanding definitely does not mean sloppy execution. Margaret is firm that every developer must leave the system in better condition than they found it. When you finally write your new feature, Claude can help you ensure that you add comprehensible code, maintain a consistent style with the old system, explicitly explain your decisions, and make the behavior totally clear. Basically, you want to make sure the next developer to come along isn't utterly terrified of the additions you just made. So how does Timothy actually take the first swing at his 430-line monster, process data? Margaret gives him a super brilliant tactical starting point. Start with the contract, the interface. Map out exactly what data goes into the function and exactly what data comes out. The internal implementation in the middle might be an absolute disaster zone, but the interface, that is a binding contract, and it is almost always clearer than the messy logic hiding inside. As Timothy gets ready to head back to his desk to finally face process data, with Claude Code right by his side, Margaret concludes with this really beautiful relay race metaphor. She says, the baton in a legacy code base is understanding. It gets heavier and heavier with every handoff if it's neglected, but it gets lighter when someone actually takes the time to write down what they learned. Your true contribution isn't just the code you commit, it's the documented knowledge you pass forward to the next runner. Which brings us to our final, slightly provocative question for you to take away from this explainer today. When you are deep in the code trenches and you finally have that sudden aha moment where an old, confusing system suddenly makes sense, will you write it down before the realization fades? Will you actually leave the system better than you found it? Look, using tools like Claude Code can absolutely help you excavate the past, but it is ultimately up to you to document the future. I hope you found this breakdown as fascinating as I did. Catch you next time.